by Anthony Steed. He's a professor at University College London. He's the hardest person to introduce because I'm a big fan of his work, so I don't want to be all giggly and stuff, but I kind of am. And Anthony's work is really, really, really foundational to virtual reality research, to virtual reality companies, to all the stuff you've seen today. If you were paying attention to some of the earlier talks today, his name was on the screen when we were talking about presence. Those papers by Mel Slater were co-authored by Anthony, so his name is all around over the virtual reality. He's going to give us a technical perspective on virtual reality, metaverse, and social VR. So I'm really excited to hear, and I just want to welcome Anthony on stage. Take it away, Anthony. Thank you.
Hello, so while I'm waiting for slides to come up, I'm Anthony Steed. I'm from University College London, and I have a problem, which is I've been working on virtual reality for about 30 years. So I got started in this area in the early 90s. And for those who are much younger than that, there was, of course, a big wave of VR back then. People were building head-mounted displays. We were building social VR back in the early to mid 1990s, but the hardware just wasn't there. So we had very good, vertically integrated applications in businesses like the car industry that could afford to build the displays and invest at the time. But obviously, for the consumer, it just wasn't there. Okay, so there are some precedents. So what I want to do today is fold in a little bit about why social VR is really interesting and what people mean technically when they say that we're going to have metaverses. So all of these things on the left have been called metaverses, and to some extent they're not wrong. So I've spent a lot of time in all of these apart from two. So the two I haven't spent a lot of time in is SimNet, because that's a military simulator network, and Habitat, because that's older than I am. So I didn't get a chance to try that. That's a 2D sort of online virtual world that you can join. So all of the others I've been in, or at least tried once. Some of them are still around. Right, so MUDs, which are text-based metaverse-style systems, are still there. You can log into many of them. I spent a lot of time as an undergraduate when I was supposed to be revising for my exams, playing in something called ABBAMUD, which was a text adventure. But the thing which is interesting is that when we talk about metaverses now, MUDs had some of those features. There was user-generated content. There were people with different roles, like wizards and game masters. There were games, right? And people would play these things for a very long time. So I don't want to dwell on them all because they're all slightly different technically. But I will just plug once. I might slip in another plug for this. I wrote a book about 10 years ago about how these things are built at the sort of networking layer. So what is actually involved in that? And I'll relay a couple of those points in the remainder of this talk. So the key thing when we move from social VR to a metaverse is that you will move between different levels of awareness of people. So social VR, as was just shown by Vladimir and was shown by other people, is very much focused about being there with somebody in a simulation of a real environment. And I'll get into in a second why that's interesting as a medium. But when we talk about very large-scale systems like MUDs or like, say, something as early as Quake, there's a mechanism for you to go and meet these people. And that's where all the hand-waving happens these days. So if I want to meet somebody in a social VR, it usually involves several rounds of negotiation over email, Slack, Discord, or all these types of things. So when people talk about cracking the sort of metaverse problem, it's really about how we find each other. Okay, it's how I find you, how we agree where to go, and how we navigate the universe of different experiences we could have. So one technical stance to take is that the metaverse is the sum of all of these systems that have gone before, and it's just a case of selecting the right environment or the right piece of software to run. So on this slide, we'll see that as you progress from sort of real-time social VR down the sort of secondary awareness, tertiary, and then start to talk about diverse, interactive and editing capabilities, publishing and persistence, access, governance, and ownership, these things get more metaversey. So, but first of all, a quick interlude, which I inserted after listening to the earlier talks, especially Christian's first talk, which was, why is social VR interesting as a medium? So why the focus on sort of full-body avatars like we saw with Vladimir's last talk, and what's the relationship to the neuroscience? So I'm a very technical person, so my first degree was actually in maths, and I thought virtual reality was just a case of getting the graphics right, which is how I got into it. But very quickly you encounter these issues of, say, body ownership, and interpretation of that. So we have done lots of work on body ownership in my team, and we have several interesting results that I could point you at. But here is a nice demonstration of some of the impacts. So the impact of this is not that you lose your head. So for those of you who have implemented this thing, the reason that there's two screens, and on the left, the avatar in green is missing its head, and on the left, the avatar in pink is missing its head, is just because you don't render the head of your own avatar, because then you tend to see the inside of the eyeballs and other sort of freaky things. But this is the situation. It's a two-person trial where the people are collaborating on solving tasks. And the task is really simple. It's to solve jigsaw puzzles on a table. Now, the important thing is that you can move around the table and pick things up and move them, right? So you're using your body, you're using your hands to pick things up. You can see, if you look closely, the Vive controllers that you might see in the experience. And you have to solve a puzzle, and you can do this puzzle jointly together, or you can compete to solve it. So in this study, where you compared people doing it in virtual reality to people doing it in the real world, so the quick question is, are these two people competing to solve the puzzle, or are they collaborating? Okay, and you can tell from their body language and their situation with respect to the objects in the world that these two people are collaborating. And when I lecture on this to my students, we spend about 5 minutes looking at this picture and going, well, they're stood shoulder to shoulder. They're obviously showing things to each other. They're obviously being able to look at the same thing. And these two people are obviously competing in the real world. So they are using, so there are many signals in this. My favorite is this one, which is English. I don't know how well this gesture translates to I'm not really looking at you, right? Because I can do this very quickly, in which case I'm not looking at you. So it's a sort of very quick sort of gesture to not let you see my eyes. And the woman on the left is shielding information with her body. Okay, so she is using, in the real world, she's positioned herself between the information which is on the table and her competitor. Now, the reason this is interesting, because if you think back to all those points made earlier about embodiment, the point I want to make is that the body is a resource. It's not just that you get embodied and you feel as if you're there. The body is then a resource for interaction. It's a resource for interaction with objects, because you can see yourself, you can pick things up and move them, but it's also a resource for collaboration in that it means things to other people, not just what I look like, but what I'm doing with my body. And delightfully, we see the same thing happen in virtual reality, which is the point of this study, which we've now followed up, is that you can see evidence that despite us not telling them that they can do this type of thing, that people in these embodied avatars start to use their body in a way which is communicative. And in this case, it's hiding information. So virtually hiding the jigsaw pieces on the table to stop the other person in virtual reality seeing that information. Okay, so so I think that's a great motivation for why to study the social situation. If we were going to focus just on the social VR, I would point out that it might mean that these systems are more accessible, for example, because you don't need to tell anybody how to use them, that this social information is coming across inadvertently or explicitly. This information is there. And of course, to speak to the panel coming up after lunch, of course, this is only if you have a very faithful representation of the situation, and there's all sorts of ways that I could subvert this. So, for example, with just looking at this picture, what happens if I have the ability to make all avatars transparent? Right? You may know that this is a real problem in online games today, right? That people fiddle with the graphics to improve their stats on games. And there's a lot of money in this. You can buy hacks to play first-person shooter games with advantages. So we might envisage that, although I think I'm obscuring data with my avatar, I'm not really, because I've got see-through X-ray vision in VR. Anyway, that's for later. But the research questions that, again, other speakers have alluded to now is what should the users, there's a whole host of them. What should the users look like? How should we build the software? How do we deal with things like latency? What controls do the users want? How will users move between different environments and different software? And how do we control access rights and so on? And I'll come back and talk about, I'm going to talk now about what research has been done in these areas and how it links to metaverses, and right at the end, I'll come back and talk about our own contribution to this, which is a software platform we invite you to come and build things with. Okay, so the key thing to point out, there's quite a lot of sections to that, but they're all going to be rather quick, is that when you come to build a metaverse, you end up with a lot of services. So there is a lot of work at the moment that's sort of focusing on how to build, say, use, for example, and not specifically to criticize this, but say blockchain for storing virtual worlds. So that's an attractive opinion or a technical stance. It comes with some downsides, but also land ownership is one tiny piece of the puzzle when it comes to making a sort of online virtual metaverse-style system. So I can recommend this paper, which is from which I've taken this picture, which is a sort of server architecture for Second Life, which has been mentioned already. Second Life is well worth studying. Not that it's going to take out, not that it's very modern in some ways, but just the sheer range of services that it provides. There are, of course, real-time services because we need to talk to each other. There are land services because you can build land. But there's also currency. There is avatar hosting. So there's all these types of different services. I'm not going to talk about the boxes because they can all be replicated. One of the most interesting things about Second Life is that it was copied. Right? So it was made open because so many people had invested so much money in it that hackers started looking at it to steal assets. The protocols were reverse engineered, and then the server backend was made open, and you can build your own servers for Second Life style clients under something called Open Simulator. Okay, so very complicated, but pointing out the types of feature you might need in a metaverse system. And yes, we'll skip that. So the key thing though is that no one architecture fits all the pieces of software we might have. And this is a direct critique, was that most metaverse companies out there that are sort of, a lot of metaverse companies out there are trying to sort of control some piece of the system, such as land ownership, such as avatars, such as naming, so resource discovery, or governance, so to insert themselves somewhere in the chain of control of these systems. So be careful. I'm going to publicize our platform later and say it's open source, so none of these problems attached to it, but there are lots of things to worry about when you adopt a piece of software. Okay, so the next thing to talk about very briefly again is the internet. Social VR and metaverses are unique. real-time graphics applications are not standard networking applications. So I give talks to technical developers about this. Unlike audio-video streaming, networking is not the main client-side activity, right? So Teams and Zoom are optimized to use your laptop efficiently. But if your Quest is doing 95% of its activity just to get the graphics on the screen, you don't have any time left for networking. You can't do a lot of it, right? So some information changes very quickly and smoothly, like player locations. Some information is very important, score, kills, avatar representations, and not. Some is not. And the internet is not built for this, right? So it's built for bulk transfer of large assets and real-time video streaming. And if everybody's talking to everybody else, it sort of struggles to cope. In particular, you can't reserve bandwidth, right? So this is a current problem for those of us who've built these things in anger. Sometimes you want, if a client comes to you or a partner comes to you and says, I really want this to work today in Bochum at 11 o'clock in the morning, can I reserve the bandwidth? No, I just have to, put my finger in the air and see if it works, and then maybe move network if it doesn't work. Right? So that's the life we exist. So it used to be better than that, right? So we used to have to buy lines and rent them in the early days, but we don't do that anymore. And then the key point, without going through absolutely everything, is that the internet wasn't built to deliver synchronous experiences. So the experiences we have at the moment in social VR are often based on servers, which are often quite remote from us, so the latency is quite high. And that's as almost engineering around the fact that the internet isn't really built to deliver synchronous experience. So some people do try and develop on this to make the experience better. Okay, so underneath the hood on most sophisticated social VR systems, there is something dealing with latency and internet issues, but there's no one-size-fits-all solution. Okay, so to talk a little bit about the current state, every platform is different. So this is I want to highlight a piece of work that we did a couple of years ago. There are all sorts of user interface issues. This is me in various VR systems. Points if you can tell me which each one is afterwards in the lunch. If you get them all right, there's no prizes. The key thing though is these are all the one on the right I hate. This is my avatar made up for, I was invited to give a talk remotely in a conference, but unknowns to me, I had to go to wardrobe first, and they chose an avatar for me, and it's got hair, right? Whereas the other two haven't, right? So these two platforms, I've put these pictures up because I cannot have hair, so I can look more like myself. So there's a lot of platforms out there. Some of them change, some of them come and gone. And I do like this work. It's only preliminary, but it's done by a master's student during her work at UCL, which is sort of doing trying to figure out how do you compare these platforms, how do you do usability across them. So that's quite good fun, and it reveals certain things. So of course, Mozilla Hubs is now an open source project just called Hubs, because Mozilla have not supporting it anymore. And if I ask you which of these two avatars is interacting with that Earth model, you might infer it's the closest, but it's actually the furthest away, right? So in that particular system, we uncovered this sort of problem with the attribution of action to different avatars. So that's quite nice finding. Okay, so the key lesson from that part is that platforms vary a lot, and there's a very open area for novel design once you have a working system. Simple problems such as privacy bubbles even, for example, are still not worked out, right? So most of these platforms have a privacy bubble so that you can't get too close. There's just a whole PhD for somebody in figuring out how those should work properly and how to moderate how close people can get to you, right? It's a key problem, but every platform's been reinventing it, essentially, from scratch. And there's a general problem of bridging between what I highlighted as secondary and tertiary awareness. That's really, how do we find each other, right? So how do we move as a group into a virtual world It can be very problematic, and not even Meta can solve that for us at the moment. Okay, right, so where to work now? There's all sorts of things you could do. I'll make these slides available afterwards, sort of what avatars, what interaction styles, what system, how to make these accessible, how to make them secure, what's the attack surface, how do we make a multi-code browser. And I'll skip on because I want to save some time for lunch. So hence Ubiq, right. So Ubiq is our social VR platform. So Ubiq is a open source under an Apache license, sort of complete system for building social VR systems. So it looks very simple when you log in, and the reason I'm getting my phone out is because it works on everything. So this is a key feature that we have, which is that screen, you won't be able to see this, but is available in WebXR, right? So you can build in Unity, so Ubiq is a Unity sort of package, but we support building to pretty much everything. So Quest, HoloLens for our sins, but WebXR being the big one. So that is, if anybody wants to have a go, this is just a web browser you can download the client from. So if you know anything about WebXR, you'll know that it has an AR mode, and then I can go in on my phone in AR in that space, walk around and meet other people. So it's just doing the scene tracking that you expect from mobile AR, and you can sort of do that on your phone. And we didn't manage to sort out how to show that with the laptop over here, so you can see it on the screen. So it's all open source, and the WebXR publishing is new. It's in GitHub. We haven't talked a lot about it because there's a couple of features that we would like to add before everybody starts using it. So that's a very simple world. This is a simple sort of Unity world where you can do something a bit like we just stole from Rec Room, which is you can join public rooms or make your own private rooms. The server is open source, right? So unlike some competing platforms, the client is open source and the server, it's just a node process. So that's connecting to a server in London, works fine over 4G network from here to London. But you can run your own server, so that's important if you want to make these things secure, so that you know exactly where the service is running. And we do have an out-of-the-box how to run everything on a laptop, including the wireless network, so you can just run a bunch of people locally. It supports about 40 people on a laptop. And underneath it uses WebRTC. So like a lot of other clients, it sort of maxes out at about 25 people speaking at once. Okay, so we originally built this for doing student work. So this demo is online. You can just download the source code. It's highlighted on our webpage. This is a student piece of work where they built a demo with 2 scales of avatars. The thing you saw moving around is a sliding block maze, which actually makes a real maze you can run around in. So this is the students trying to get the lab demonstrators, my teaching assistants, stuck in a maze inside. And I would, anybody that's familiar with this, I defy you to think about how you would do avatars at 2 different scales in any of these platforms, because that is tricky. But anyway, if you're interested in that, or your students are interested in following it up, you can download the source code. We encourage our students to make their source code available on GitHub if they want. Okay, and then here's the type of thing that we do in the lab. This is a demo connecting Quest in AR mode, HoloLens in AR mode with Quest in VR mode. We do mixed reality as well, and that's my office. Can we do that again? Yeah, so that's my office at UCL. If you've ever used the HoloLens, my office does have windows, except the blinds are shut, because that makes the tracking a lot more reliable. So that's for the purposes of running an experiment. And this is something we've followed up with some submissions to some recent conferences about how do people understand mixed reality as a shared space when one person is in the real environment and one is in a virtual copy of it. Okay, so that's me wrapping up, I think. Done that very quickly. So you can download this at ubiq.online, and you can email all of us at ubiq cs.ucl. It's at the end as well. So things to discuss, and I'm happy to talk with people today or tomorrow about this. Is it just enabled by a smarter web browser? We support WebXR. I don't think it's a complete solution to the problem. The problem is not what the client uses to experience. So our WebXR runs inside the Quest's browser, right? So you can ship our multi-user experiments to anybody without them installing an app, right? Which is quite interesting, but it's still not a solution, right? Because there's something about running in the web browser, in particular the security model, which means that that's not a very general solution. It's interesting for us, but it's not a very general solution. Will a game engine win? Right, so should you invest in Unity? And the answer to that is probably the wrong level of abstraction, right? Will a new publishing engine win, right? So think about the history of 2D media, so Flash and things like that, right? So Adobe having tools that can build these things to publish. So Unity is a publishing engine as much as it is a real-time engine, right? It is a thing to publish content. So can it publish to something else? It's publishing to WebXR, right? So that's a little weird. Could it publish to other things? And can we think of the problem in the wrong way? So if I had another half an hour to rant, it would be that why are we building apps, right? Why are we building things that run and take over the whole screen? It's absurd, right? Don't get me started, right? It's a sort of thing which we don't do on Windows or Mac. It's something that we seem to have inherited from apps on mobile phones, which is unnecessary, right? So if I can run a VR app with an AR app alongside it, and we have a demo of that in Ubec I can talk about if you're interested, then it's one experience with two apps running at the same time. So what does that mean, right? So I have an interesting demo along that. Can we view multiple apps and somewhat similar to the window manager problem that we've had in Windows, because that's where accessibility happens on desktops, right? So everybody can fiddle with all the apps that are running, and there's just no same level of access to VR or AR at the moment. Okay, so to conclude and get us to lunch, the internet isn't really architected to support social VR and larger scale metaverses. If you think about the problem of having 1,000 people interacting, or even just something slightly, this conference with everybody in a social VR, you would struggle right now to do that. There's a lot of research to be done on multi-server architectures and sort of server-side routing.